Hello everyone, welcome to this session on qualification of glassware with special focus on the pipettes. So if you are ever wonder how a pipette gives exact amount of solvent to you, this video is for you. To qualify or calibrate a pipette, you need just few essential tools like a pipette itself, some amount of distilled or deionized water, a clean container, a precise analytical balance, and a calibrated thermometer. Let's see how each step ensures accuracy and reliability. The first step is clean and precondition the pipette. Ensure the pipette we are using is clean and dry. That should not contain any moisture. Now rinse this with tap water, after that with the distilled water. Next step is weigh the empty container. Weigh out an empty container which is free from moisture during weighing and denote that as W1. Let's take an example. We have got W1 is 21.20 gram. The weight of empty clean and dry container is 21.20 gram. Now take the container and set aside. Now take a pipette, the amount of solvent it can hold. Next step is aspirate distilled water of a certain amount. After that, dispense that distilled water in that weighing container which is denoted as W1. Let's take in our example case, we have taken 10 ml of distilled water. Now this container have the amount of water we have taken or drawn by the help of that pipette. So our next step is weighing of the container which holds dispensed water from the pipette. That we will denote as W2, the weight of container plus water from the pipette. In our case, we have got W2, that is weight of container with water is 31.50 gram. Then we need to calculate the mass of water by the formula W2 minus W1, where W2 is container with water and W1 is the weight of empty container. This will give us the mass of water. In our example, W2 is 31.50 gram and W1 is 21.20 gram. So we are getting the mass of water is 10.30 gram. Now let us convert this gram into ml. Rather we can say mass into volume. For this we will use the density of water at a recorded temperature. So at 25 degrees Celsius and 1 atmospheric pressure, 1 ml of water weigh about 0.99707 gram, and we have got mass of water that is 10.30 gram. So we can convert that into volume by volume equals to mass of water, that is 10.30 gram, divided by density of water, that is 0.99707 gram. So we are getting the pipette volume is 10.33 ml, but as per standard or as per the pipette it is written as 10 ml. So for that we need to go for checking of error, calculation of error. So when you compare the measured volume with the set volume, measured volume which we have got and set volume is which is set by the manufacturer and written in the pipette. So we can calculate the percentage error by the formula percentage error equals to measured volume minus set volume divided by set volume into 100. So the measured volume we are getting is 10.33 minus set volume is 10 ml divided by set volume is 10 ml into 100 to convert that into percentage. So the error we are getting in this case is 3.30 percentage. To make it very precious, we need to go for repeating of the process. We need to perform these trials 3 to 10 times, and after that we will take average of that error. Here you can see a chart having serial number, W1 weight, W2 weight, the weight of water, that is W2 minus W1, and the percentage error. So we are getting the average percentage error is 3.26. Now we need to check this is whether this is within the limit or out of the limit, that we call as acceptance criteria. For micro pipettes, the acceptance criteria is plus or minus 1%, and for other volumetric pipettes the acceptance criteria is plus or minus 0.1%. But as we are getting 3.26 percentage of error, we cannot continue with this pipette further. So this is how you calibrate or qualify a pipette.